All right, Unit 5, Day 5, solving
Nope, it's a different
exponent equations.
Calculating 4?
So let's first clarify what we're doing. On that last test, or that last worksheet, that was, all of those were expressions. We were simplifying expressions. There wasn't an equation to solve. You didn't get x equals anything. Today we're solving, and solving equations kind of goes together. So your answer is going to be x equals 12. But it probably won't be 12. It'll be x equals natural log of 12. So you're going to start with an equation, you're going to do the process, and you're going to end up with an x equals as your answer. Exponent equation means that the the variable is in the exponent. So 3 to the x plus 5 equals 12. That would be an exponent equation that we want to figure out how to solve. There's two types of these. Very different types. Some people like one versus the other. I don't know that one is easier than the other. I think it depends on what you're good at as to which one you think is easier. So the first type is that both bases are, or can be, which that seems a little bit weird, but we'll get to that in a minute, the same. Both bases are the same, or can be the same. You know what? Let's not talk about the second type. Let's just work the first type, and then we'll talk about the second type in a minute. I mean, we got to do both types, but rather than tame both types and then work them, we'll go one type at a time. So both bases are the same or can be the same. And the second type is they're not the same and can't be the same. So an example would be 3 to the x equals 3 to the 4x minus 5. That's the easy one. So what do you think you would do first on that? Okay. So technically I wouldn't say you would delete the 3, but mathematically that's not what's happening, but in effect that is what's happening, right? If you got 3 to something equals 3 to something, the two somethings have to be equal to each other. So I would not phrase it as delete the 3, but in effect you deleted the 3. And you turn this into, algebra 1 level stuff here. So negative 3x equals negative 5. X equals 5/3. That's the easiest kind, when the bases are the same. Now, so are the same is the easy kind for sure. Can be the same is sometimes the tricky part.
Make them the same by finding the greatest common factor.
You are going to make them the same, so let's figure out how to do that. That's not how you do it. 27 to the x equals 9 to the x minus 4. So I can't delete the 27 or the 9 because they're different. So I can't just say, let's let the exponents equal each other.
You can divide them by,
something's going on with 3.
Simplify it.
So I can't really divide both sides by 3 because it's legal. It just wouldn't help. Instead of, let's think really carefully here. How else could I write? How else could I write 27?
3 squared, 3 cubed.
3 cubed. So I did not cube both sides. I did not square root both sides. I didn't divide both sides by 3. I rewrote 27 as 3 to some power.
And now you're going to do 3 to the 2
And I picked 3 because I knew that I could rewrite 9 as 3 to some power as well.
Does that mean
2.
it would be 3x equals 2x minus 8?
Yes. Skip the step on me. Power to a power you multiply. So 3 to the 3x equals 3 to the 2x minus 8. That would be a step that some of you would skip because you kind of do it on the fly. And then now you can wink, wink, delete the 3's. You're not deleting the 3's. You're setting the exponents equal to each other.
Get rid of that, don't you?
So x equals negative 8. So the can be the same exponents or the same base is sometimes tricky because you've got to be able to figure out how do I rewrite 27 or 81 or 16 as something else.
But what if it's not?
What if they don't work?
Yeah.
That's type 2. So yeah, if you can't do it, then you got to switch.
So then this would be the easier way.
So it's the easier way if you know your powers of 2's and 3's and 5's. If you don't know those powers, then you'd be stuck there and you'd be like, well, what am I supposed to do?
Yeah.
So if you know the powers, then it is the easy way. But it's not just knowing the powers, it's knowing... Wait a minute, something's going on with 7 here. 1 over 7 to the x.
Wait,
It's just,
you can put a 3.
Like
1/3.
7
Okay, so definitely on the right side, that's the same thing as 7 to the 1/3.
and the other one is 7
To the 1 over x.
Not 7 to the 1 over x. What
Seven's the
what made it flip? What sent it to the bottom?
Negative.
Negative.
7.
So 7 to the negative x.
Yeah, okay.
So yes, once you get them to be the same base, they're easy because then you just grab the exponents. But getting them to the same base is sometimes the tricky part. Let's do one more of this type, and we'll go to the other. 1 over e to the 5x equals 1 over e to the x squared plus 6.
So would you just make it negative 5x and negative x squared?
That's what I would do. They're flipped, so we can unflip them by putting a negative on the exponent. I guess we're not unflipping them, we're flipping them back. Either way, same thing. And then now you can delete the e's. Oh, the mathematician in me cringes to say that, but that is kind of what's happening.
It's not gonna.
We have to factor.
Yeah, we will have to factor, but before I factor, I need to get it equal to 0. And you can move it to either side, but one side's going to make life a little easier, right? If you have a positive x squared, that's generally the way to go. Oh, this was so unfortunate. On calculus, we had a problem that involved factoring, and there was a lot of hard calculus, but a bunch of people missed the problem because they didn't factor correctly. Seriously, it was frustrating. They'll be frustrated when they get their test back.
Gosh.
And it was early in the problem, so they couldn't earn a bunch of points because they just kind of took off down the wrong path.
Mm-hmm.
Let's see, x minus 3 minus 2. So x equals 3 and x equals 2. And again, in calculus, this step would have come early in the process, and then they had to do something more with 3 and 2.
Early.
But if you factored wrong, then you didn't have 3 and 2 there, and so the rest of the problem was kind of a waste. All right, so if the bases can be the same, I guess I'd say if you can make the bases the same, it's an easy problem. Getting them to be the same is sometimes tricky with negatives and fractions and just knowing your powers. But once they have the same base, then yes, delete the base. Ugh, pains me to say that. Type 2. if the bases, and this is more common, as you might expect. Like that was kind of a special case that we were just looking at. Definitely rigged problems if the bases are the same, make it a little easier. But if the bases are not the same, and really can't be the same, like there's no adjusting to do to get there, well, I guess I'll give you the answer, the technique right now, and then we'll see how it looks, how it works. We're going to natural log both sides.
But didn't we just do the part where that had to be not asked if never mind?
We're going to natural log both sides. So this is a new, I mean, natural log's not new, but this is a kind of a new technique for solving equations. Like when you first learned solving equations in Algebra 1, like the first thing you did was add 3 to both sides to get x by itself, right?
Mm-hmm.
And then you had two-step equations where you added 3 and then divided by 2. It's like, whoa, mind blown. And then later you learned how to square root both sides or square both sides. Now we're going to natural log both sides. So the algebra rules still apply. You still got to do it to both sides. And we'll see sort of why and how this works as we work a problem. E to the x plus 1 equals 5. Well, I can't make this a type 1 problem, right? I can't rewrite 5 as e to some power.
Can you make?
I mean, it is, but it'd be a really weird power.
Natural log to both sides.
So I'm going to natural log both sides.
So you make ln e x plus 1 equals ln 5.
But doesn't ln
But then you can
cancel?
ln
Okay.
you can cancel it out.
ln e cancels. ln e is 1. You're right, but I don't have ln e yet. What property could I use, though, to get to ln e?
Ln x plus 1 e.
Where can this x plus 1 go?
Down to
Oh, in
that.
front.
And that's the key to the whole thing. That's why we natural log both sides, is we get rid of the exponents. So really, it's not even an exponent equation anymore.
So it's just x plus 1 equals ln 5.
So I'm showing my steps, and you guys are flying ahead of me here. But yeah, because the natural log of e is 1. So x plus 1 equals natural log 5. So what should I do? So the right-hand side's weird, but ignore the right-hand side.
Minus 1.
Subtract 1 from both sides.
X equals ln
5 minus 1.
Done.
Be careful, that's not natural log 4, right? That's natural log of 5 minus 1. And we're going to leave that as our answer. Like,
Well, this hand. Okay.
algebra. You're just shaking your head now.
Second problem, and we're already throwing wrenches.
Yeah. Any idea on what we do first on this?
You would.
What don't you like
You
about
can
the
cancel
problem?
out the e.
Tell me what you don't like about it. Fraction.
Wait. Can you
Okay.
cancel out the ex completely because the one's on the bottom, one's on the top?
Ugh. Can I cancel out the e to the x's? Because one's on the bottom, one's on the top.
One is a fraction, one is a
No, one's got the minus 1 on there, so that won't work. So I'm not gonna phrase it that way. Someone said multiply 2 to the denominator. I'm gonna multiply this to the other side. Actually, I'm gonna multiply both sides by
I haven't wrote it down yet.
4e to the x minus 1. What does that? How does that help me on the left-hand side? I mean, they just cancel, so the left-hand side is great now. 3e to the x. The right-hand side, let's see, that would be 8. E to the x minus 2. Okay, that was a big important step, because now we don't have fractions anymore. what do you want to do next?
Subtract e to the x, or 3e to the x.
So yeah, you could do this a couple ways. I could subtract 8e to the x over.
No, I'll do it the other way.
You want to do it the other way.
Yeah.
That way you get positive numbers.
Yeah.
I like that. That's
E
good
to the
thinking.
X equals negative positive 2. And then you just
Wait,
got
so then
to-
now you have to divide.
Now you
Wait,
do
no,
ln.
you gotta do
Okay, so I could do the ln now, but it's going to make things ugly later.
Wouldn't it
Why don't
be
you
x
just divide by
ln 5?
Let's divide by 5 first.
Okay.
You could natural log now, but it's going to make a mess. Let's divide by 5.
So e to the x equals 2.
So 2/5 equals e to the x. Now we'll natural log both sides.
And you can get rid of this other x, that thing, e, get rid of that thing.
So x equals natural log of 2/5.
X out that thing.
When you get to the point that you're ready to be done with the exponent, when you're ready to get it out of the exponent, then you natural log both sides.
Not the answer. Oh, yeah.
So yeah, that's the answer, natural log 2/5.
X equals natural log of 2/5. So can you do one that doesn't have an e because, or is it always going to be a natural log?
For us, they're always going to be e.
Okay.
But it works the same way. You just it wouldn't cancel out. You'd have natural log of 5, and you'd have to divide both sides by natural log of 5.
Okay. So
Most of the time, it's going to be e.
Okay, and like on the test.
For us, it's going to be e.
Okay, so it'll always like cancel out L and E. Okay.
Yes.
That's all.
Yes.
Divide by 5
Tori.
plus-
Why don't you expand it to be ln 2 minus ln 5?
It is equal to ln 2 minus ln 5. You're right, and so that would not be wrong. So yeah.
So we start with dividing by 5.
So number 7, 5 e to the 3x plus 1 equals 30. What should we do first?
Divide by 5.
Divide by 5. E to the 3x plus 1 equals 6. What next? Now we can natural log both sides. That will fix the exponent thing for us. So 3x plus 1 equals
Got the answer.
natural log of 6. So again, this is where we know how to do the algebra. The right-hand side looks ugly, but we still do the same algebra steps. Like, ignore the natural log 6. If you had 3x plus 1 equals something,
Minus 1.
what are the two things you're going to do in order to get x by itself?
Get rid of
Subtract 1 and then
Divide by
divide by 3. So, yeah, the right-hand side's going to start looking ugly, but we're still
6 minus
just getting x by itself. 3x equals natural log 6 minus 1.
over 3.
And then, yeah, you could just put all of that over 3. So there's a couple ways to write the answer from here.
Is that correct?
That would be correct.
There sounds like there's an or there.
Well, since a lot of these are multiple choice, would you recognize that that's the same thing?
No, I wouldn't.
Absolutely not.
So,
Not a chance.
I mean, those are equal and equivalent, equally acceptable answers. But if you know, I don't know which one the multiple choice is going to be, so you have to be able to recognize that those are the same thing.
Wait a second.
Why is there 1/3?
But it's not to the power of 1/3.
Why is there a 1/3?
Because I understand the minus 1/3. Why is there a
There's no power to the 1/3.
Because I'm dividing it all by 3.
No, but isn't that a power to the 1/3? Where there's an e.
If you'd rather do it, kind of show it that way, you could. Is that a power of a 1/3? Well, yeah, if you wanted to get like really fancy on different ways to show this answer, you could do that. I don't think that's going to be one of the answer choices. That wouldn't be wrong.
Would you willing to bet your life on that?
He's like,
I was like, I'm not willing to bet my life on much. So, no on that
That's
one.
fair, that's fair.
So, yeah, a lot of this comes down to, do you recognize that those are all the same thing?
no, but yes.
I hope so.
No, but yes.
One more.
But they are.
E to the 2x equals 3 over e to the 4x. Last one. E to the 2x equals 3 over e to the 4x. Yeah.
Wait, you can. If
What
you-
can I do?
if
What
you-
don't you like about the
you
problem?
can
Fraction.
Fraction, but 2, you can simplify the 2x and the 4x thing.
So if I don't want a fraction, I can multiply
Both sides by 2x.
both sides by that denominator. So great news on the right-hand side.
That's just 3.
That's just 3. That's the reason we multiplied by e to the 4x. To make that e to the 4x go away. On the left-hand side, now I have to remember my exponent rules. E to the 4x times e to the 2x
6x?
is e to the 6x. Just like
Gosh,
x squared times x cubed is x to the 5th, because you add the exponents.
I got you.
Add the exponents, e to the 6x.
Natural log of
Natural log both sides.
So then,
3 divided by 6.
So 6x equals natural log 3.
Out of 3 over 6. That's a choice.
If I write it like that, would you be okay? 1/6 ln 3?
why can't you just put it in the way that we're going to work?
Just.
That's fine too. That's.
Yeah, but why can't it be like that?
He's gonna.
Be careful. Is that the same thing as
I swear.
that?
I don't know.
Can't do that. You're dividing natural log 3 by 6, not just 3. So be careful.
Can you show the 1/6 like how it was before?
So like if I want to get rid of, one way to get rid of the 6, I could divide both sides by 6. I could also multiply both sides by 1/6. Is that what you're asking? Okay. So if I think multiply by 1/6, I sort of land here. If I think divide by 6, I land here. But you need to be able to recognize that those are the same thing.
Yeah.
So write it either way. If it's a free response question, either of those answers would be acceptable. If it's multiple choice, well, I don't know how they're going to put it. You have to be able to recognize.
He's definitely gonna put it on that.
Probably going to put it like this.
Oh, great.
And again, if it's free response and you want to get creative with me, I could write that as natural log of the 6th root of 3.
So we have to make it so you have to solve it.
Right. You would make me be doing work if you wrote it like that. You're like, yes, finally, we turned the tables on Mr. Wolf. Yes.
Alright, let me write that down.
Because all of a sudden, we're motivated to do some pre-cal to force me to do some work.
Yeah.
That would be one where I would probably, in grading your test really quick, I would probably mark that wrong. And I'd hand it back and you'd be like, hey, wait a minute, are you sure? And I'd be like, oh, yeah,
Extra
dang it.
credit, bud.
So if there's a problem that you can make the bases the same, but you don't know how, could you use the second one to figure that out?
So that's a really good question. The question was, if there's one that you don't know how to make the problems the same, can you use the second method? And the answer is yes,
To an extent.
carefully.
Like number 2, let's say.
Like, let's say on number 1, the right way to answer it. So go ahead and get out worksheet 5 and we'll start working it. And I'll answer Crystal's question because that's a good one. So 2 to the x equals 2 cubed. So this is an easy one, but it'll make an easy one to answer your question on. So what does x equal? 3. Because we deleted the 2's. Oh. A mathematician dies every time you say that.
Delete the 2.
So you're like, delete the 2, delete the 2, delete the 2. Cruel people. Okay, so Crystal's question was, well, what if, okay, so this is an easy one, but what if you got one where you're like, I'm not sure how to get there, or I forget how to do it. Can I natural log both sides and come up with the answer?
Delete the 2.
Natural log 8 divided by natural log 2. It's like, wait a minute, is that 3?
No, you would think that would be like 4.
You might think it would be 4. It's not 4 though.
Definitely not 3.
Let's see, I could rewrite 8, but this gets back to, at some point I've got to rewrite 8 as 2 cubed.
Okay.
So, Crystal, the answer to your question is, can you do it that way? Yes, and eventually you need to know that 8 is 2 cubed. Now, if this was a calculator test and you had a calculator, then this would be fine because you'd type this in the calculator and you'd get 3 and you'd be like, oh, that means there was an easier way to work the problem. Oh well.
So, 2 things. 1, on the test, are we going to have a calculator?
You are not.
You use the calculator?
That was just a check.
No.
Yes.
And then, yeah, you said we could use the calculator.
I was wrong. I'll just go with that.
You gave us
Yeah,
hope.
you used the calculator. You told us the calculator app,
And
so you gotta
then-
use the calculator.
And then Mr. Wolf, and then my other question was like, so what about, never mind.
While y'all are answering questions, I'm here working the homework problems.
Hey.
That's why we're
Wait a minute, what's going on here?
No, we just copied down the whole problems.
Here's a fraction issue for some of you.
Yeah, let's keep asking questions so you can keep doing this.
If 2x equals 1/3, then x equals...
Equals 1/3 over 2.
Yeah, but I don't want to write 1/3 over 2.
Why not? It's right.
It won't. That certainly won't be the answer on the multiple choice test. That's not
0.33
wrong.
repeat over 2.
That definitely won't be the answer choice on the... How about we multiply both sides by 1/2?
Huh? Wait, what? You mean 1/3?
No, I mean multiply both sides by 1/2 to undo the 2. You can keep it, change it, flip it. You land at 1/6. We need to back up and do a lesson on fractions, then maybe.
Well, Tyler, the way you can do it is you can multiply both sides by 3, get 2 or 6x over 1. Or
Yes.
6x equals 1, divide by 6, get 1 over 6.
Mr. Wolf, did you do number 3?
Number 3.
We're going to multiply that.
So how could I rewrite 16? 2 to the 4th to the 2x. And we already said 8 is 2 cubed.
You just keep everything.
What do I do with the...
Multiply.
And then go ahead and say it. What do I do next?
Delete the
Delete the
2's.
8x equals 3.
Delete that 2.
Have you never heard that before? Like,
I mean, that's the way students say it. It's just...
Delete the damn 2.
It's like... The official way to say it is, if the bases are equal to each other, the exponents have to be equal to each other. So we'll set the exponents equal to each other. It is a lot quicker to say, delete the bases.
yeah.
Even though it's like...
What about cancel out the bases? Would that be slightly better?